It's not to say there isn't anybody out there. It's to say there's an observation here that we don't see anyone at the moment. So why might that be? So you're right, it might be everyone hides, or it might be that given what we know about the history of life on Earth, it's just very rare that complex living things emerge.
There you are. Just arrived at Gliesa 667. Better get ready. Set the drone to survey mode and prep for atmospheric analysis.
Yeah,
This could be it, you know? The moment we finally make contact.
I know.
Would undoubtedly be humanity's greatest discovery, finding evidence of intelligent life beyond our world. Imagine civilizations out there, perhaps millions of years ahead of us, with technology we can barely conceive, waiting silently in the depths of space.
The first thing to say is it would be remarkable if we found microbial life, because we would like to know if life began in more than one place in the solar system, given the right conditions. And I've spoken to a few colleagues who work on the Europa Clipper mission at JPL, who said that if we don't find life on Europa, if our picture of Europa is correct, and there's this long-lived ocean and active geology and so on, and we still don't find life, we might start to think that even the origin of life might be rare. But you're right to say that when we talk about aliens, if we use that word, then people are really asking, is there anything out there that we can talk to, right? Is there things like this out there? That's a whole other question, perhaps. Let's say that we find that life began on Mars and Europa. So let's say we find microbes. Then, as you say, the question becomes, how likely is it that given the origin of life, at some point you get intelligence? Complex living things and then intelligence at the civilization level. And again, of course, we don't know. But we do have the only piece of evidence we have that would allow us to make a guess is the time that it took to go from the origin of life to a civilization on Earth. And that time is something like 3.8 billion years. So let's say around 4 billion years. The Earth is 4.5 billion years old. So we have two pieces of evidence, really. One is that life began pretty much as soon as it could on Earth, give or take, right, when the Earth had formed and cooled down. But then it took something like 4 billion years to produce a civilization. And that is a long time. That is about a third of the age of the universe. And so if that is typical, and again, to emphasize, we don't know, it's the only piece of evidence we have, but if it really does take many billions of years to go from the origin of life to things like us, then you could argue that the number of civilizations might be quite low in a galaxy like the Milky Way. And that's just based on the observation that we live in a violent universe. Many stars don't live for 4 billion years, for a start, right? So you need a particular kind of star. You could argue that the longest lived stars, which are red dwarf stars, which are the most numerous in the galaxy, are not conducive to the evolution of complex life because the planets have to be very close to the star in order to be warm enough in what's called the habitable zone around the star. If it's a dim star like a red dwarfs are very active stars. You get planets that are what's called tidally locked, which means that one face always faces towards the star, in the same way that our moon always presents one face to the Earth. It's the same effect. So that doesn't seem to be a setup that you could imagine produce an ecosystem as complex as ours.